How's it going, YouTubers? So today I got my portable house fire running. It's like 38 degrees, 39 degrees here in the tin shed, and it's pretty cold. So once that warms up, I'm going to be busting out two welders, and we're going to be comparing them so that you can be better educated on what will work for you. So let's get into it. So it finally hit 45 degrees here in the shop. I could take my jacket off, a little bit warmer. Today, we are going to compare two competing products. Well, not really competing with each other, but definitely competing for your money. And that is the Titanium Stick 225 and the Esab Rogue 200, which the 180 is very similar to this. This just has high frequency for TIG and a little bit more amperage, but they function very similar. And we're going to look at what you really get for more money. And this isn't going to be a bashing Harbor Freight video by any means, because as you guys probably already know, I really like this stick machine, and I think that you can't get a better functioning stick machine than this. And the reason I say that is you can definitely get a cheaper stick welder than this, but it's not going to weld as good as this, is what I'm saying, because this will weld with 60-10, as will this. And this guy will work dual voltage, 120-240, and it also has a pretty accurate readout. So your set point versus what it actually outputs is pretty accurate with this guy. Same thing likely with this. But we're actually going to test the electrical efficiency of these as well to kind of get an idea of how good they are, maybe for a generator or just on your normal household electrical system. So there's going to be a ton of comparisons in this video. And again, this isn't meant to crap on this, because this is 250 bucks. This is like 1,000, and the smaller, the 180, is still like 850. So miles different in price. What do you really get for that money? Let's get into it. So first things first, let's talk about the front of the machines. The Harbor Freight is very typical of the lower price stick welders. They typically just feature a straight dial, okay? And that's fine if it's accurate, which I have tested this in the past, and it is indeed accurate. If you set it for 120 amps, that's exactly what you get. This has a button to flip between voltages, which is interesting because this is a dual voltage, but it requires you to manually select the voltage. Now, if you were to start it on the wrong voltage, it's going to display a bunch of lights and it's not going to like you. So you got to shut it off and then flip it back. The power switch is on the back of the unit as well. Now, this unit here features smaller DINS connectors than the Esab. I believe they're DINS 25, and we'll look at the cables a little bit later. But features smaller DINS cables, likely smaller copper wires for the stinger in the ground. But again, very simplistic features here. Front of it's made of plastic, as are most welders nowadays, and I'm okay with that. I know a lot of you old school guys won't like that, but you know what? It is kind of complicated to make something like this out of metal, and it weighs more, so I get it. Hey, it is what it is. Times change, right? Now, this machine goes down to 15 amps all the way up to 225. So this actually has more output capability than the Rogue. So that's quite interesting. Now let's look over here at this guy. So most more expensive welders, especially with stick, are going to have a LCD display. This will indicate output amperage based off of this wheel rather than just a rotary knob with a dial. So a little bit easier to get things dialed in. How much is that necessary with stick? Well, honestly, you can stick weld just fine with this. So it's not a huge deal. Because this can TIG weld, that is handy to have. So that's is a good feature. Now, this uses buttons to go through menus. We'll skip the TIG functions on this because that's irrelevant in comparison to this, and the 180 does not have, the Rogue 180 does not have those TIG high frequency features. So anyways, using this button, you can control what's called arc force. And I made a whole video on that. I'll put a link in the description if you want to read what arc force is about. It has adjustable arc force, it has adjustable hot start, and it has adjustable pulse, but that's for TIG. So kind of interesting features there. Do you need adjustable arc force? I would say adjustable arc force is a great thing to have because it allows you to dial in certain rods to run a way you prefer. If you're starting out, it's not a huge difference. The adjustable hot start is nice because you can dial in to where the start's nice and hot and you don't have issues with lack of penetration on the start or porosity. So that is kind of a nice feature. This welder has built-in hot start. It has a boost in amperage initially by, I don't know, maybe 10% or something, and then it backs down. So it does have a little bit of a hot start. Both of these have fairly high open circuit voltages, which aids in starting rods. When you have really low open circuit voltage, like 30, 40 volts, you have issues starting rods because it's going to take a little bit tapping and to get the arc started. So these things, neither one of them have an issue starting any rod, in my opinion anyways. Now when you look at the DINS connectors down here, these are considered DINS 50 or DINS, I think it's 3550. Much bigger, heavier duty, so that would be an upgrade on this. Physical case material, this seems to be a little bit better of a plastic, probably some form of glass bead or glass fiber reinforced. This seems to be, like you listen to it, a little bit cheaper of plastic, but it still seems pretty durable. And I can tell you, I've owned both of these, well, the 180 prior to this that I used on a ton of jobs, same thing with this guy, and they held up pretty good. So with the front covered, let's look at the backs. So on the back of these units, they're very similar. Okay, you got your vents for your fan, you have your power switch. This has a nice rotary switch. They both have a cord retainer that is basically the same style. This guy's a little loose here. I found that when actually this one is too. Imagine that, a little bit loose. The cables on these are completely different. This is a far more flexible cable than this. This is like a hard UV resistant or something. This is a UL rated cord, as is this. They both are, shockingly. One thing that might shock you to hear is that this Rogue, and I don't know if you can see that right here, 14 gauge. This is rated, it's 12 gauge wire in this. So despite this cord being bigger in size than this guy, this actually has smaller wire. Quite interesting. I know if you're at least a little bit electrically inclined, you would think, my God, 14 gauge wire. How is that possible to put on this and not melt it? Because it's a 200 amp capable machine. Well, I can tell you a couple reasons why that is, and we're going to find out later in the video, but this thing is so electrically efficient that it does not actually draw that much current, and you can loosely, and keyword loosely, get away with running 14 gauge. I would have liked to have seen 12 gauge on this personally, but hey, it is what it is, and this machine does work good. Now, this does have a gas port down here, which is for TIG. We're not going to use that today. Now, I got to say this. Every Harbor Freight tool I've ever had, what fails on it? The switch. This switch, I don't know who they buy their switches from. Well, of course, the cheapest supplier, but everything I've owned, belt sander, sandblast cabinet, winch controller, this size switch, which all of them had, always fails on me after a while. So my guess is, if you use this a fair amount, this sucker here is going to fail, you know, in a couple years. And luckily, it's pretty easy to replace them. Now this, much heavier duty switch, I've never had one of these fail on me on a welder, so, or anything else I've had. I wouldn't worry too much about that. It's also bolted in, which is nice. It's just a heavier duty setup. Now, as far as the cases are concerned, let me just look at the top here. They both have carry handles, which I really like. This one you can run a shoulder strap over. Honestly, I rather just have a carry handle. It's so much easier to carry it around than to use that BS shoulder strap. So I like that. Size-wise, you can see the Harbor Freight's a little bit wider. This is a little bit longer. They're about the same height, I would say. I mean, within a ½ inch, really no difference there. So it's really the width of it is wider with this. Now, weight-wise, Harbor Freight's definitely lighter. I'll put the actual specs now, not by a whole lot, but both of these machines are portable. So for around the house, you'll be really good around your garage, even a little bit of portable work. All right, let's talk a little bit more about some of the other things that you need to be concerned about with these. So one of the interesting things about these two machines, they're both 120, 240 dual voltage, okay? They can run on both, but there's a staggering difference in their capability. This guy on 120 volt is only capable of 70 amps output, which that's pretty low. Like you couldn't run a 332 7018 at that. You'd be limited to maybe a 6011 or possibly a 6013. And that's about it. This guy on 120 volts is capable of a set point of 110 amps. And you're probably asking yourself, well, why on earth can this output so much more power than this? And let me explain. And I will actually show you in test results why that is. So this machine is so electrically efficient that it is capable of outputting more power off a given input power because it doesn't waste the energy. So a normal stick machine, say a transformer machine, might be 40-50% efficient, which means if it takes 4,000 watts in, it's only going to give you 2,000 watts at best output. This is over 80% efficient. This one, which we're going to find out today how efficient it is, probably far less than 80%. My guess is 60, 65, is basically spending more of its input energy wasted in heat and just losses than this. So all of that extra loss is recuperated in output. The second reason that this likely will output 110 amps, or at least that's its max set point, is because this arguably will overload a 20 amp breaker. And I know you're telling yourself, or at least probably telling me at this point, well, they can't overload breakers. And that's where you'd be wrong, but it's not your fault that you're wrong. Welders like these things are intermittent use electronic components, okay? Because of the intermittent use, it's very common, virtually every 140 amp MIG welder or any welder that runs on 120, they all overload the breaker. And they do that because they're only overloading it for 10, 15 seconds for a weld, and then you're done welding for a little bit. Breakers in your house have a thermal curve and a magnetic trip. The thermal curve of the breaker, it takes time before it trips. And if you're only overloading the breaker by 5 amps on a 20 amp breaker, it might take 40, 50, 60 seconds before that breaker trips, okay? Well, in that time frame, you're already done welding. The breaker's thermal curve, the wire or whatever it uses inside to trip it, cools off and it doesn't trip the breaker. That is how this is able to get more output than you would normally get, okay, out of a normal breaker. This guy right here, which is limited to 70 amps, my guess is they engineered and designed this to where it probably does not overload a breaker on 120. We're going to find that out though in testing for sure. And it goes without saying, you need a dedicated 20 amp 120 volt circuit to run either one of these and get their max output. If you're in a garage and you have a 20 amp circuit and you have this plugged in and that same circuit has a bunch of other things, a refrigerator, your lights overhead, you're never going to get the output that you're going to see me get in this video because you're going to trip your breaker, okay? So a dedicated 20 amp, 120 volt to get these. And then of course, both of these run on 240 volts, and that's where you're gonna get their max output. Now, I'll be honest, I don't know if I'm gonna be able to get the max output out of this machine at 225 amps. It's gonna depend on how efficient it is as to whether or not my generator can output enough power to feed it. So I don't know on that, but we're gonna get at least a practical range of stick welding rod amperages to determine how efficient they are and compare them. With that said, I'm gonna get set up, get my generator fired up, get some material here and a full set of testing equipment, and we're gonna look at exactly the efficiencies of these. All right, my apologies for how janky this setup is here, but hey, is what it is. So what we have here is the welder. We're gonna start testing it on 240 volts first, then 120. This meter here, and by the way, I'm gonna have a close-up of this so you can monitor this yourself, but this is just an overview. This guy, which is labeled output amps, we are gonna look at DC, what the actual output of this machine is. This is output voltage, so we're going to look at what the open circuit, aka you're not welding, what that voltage is, and then we're going to look at what the rods run at for voltage. And if you know anything about stick welding, you know that it runs on fixed amperage, variable voltage. Your voltage is dictated by your arc gap, and it's also dictated by what rod you run. 6010 runs at a higher voltage than 7018. So output voltage, and then this is monitoring the 240 volt for amp draw. So what we're going to do here is basically determine how many amps is drawing at 240 volts, and we're going to calculate out the efficiency by looking at what its output actually is. So we're going to average the output amperage and voltage, come up with a wattage, and then subtract that from the input wattage, and that's going to tell us how much we're losing, and it'll also give us, with a simple formula, the efficiency of this welder. Now, my prediction is it's probably going to be around 60% efficient. If it's over that, great. If it's under that, boo-hoo, I guess that's not that great, but it is what it is on that. Now, for the first test, I'm going to run 90 amps with 7018 332, and I'm going to run the same amperage with 6010 1/8 inch. Then I'm going to bump it up to 120 and just run a single bead with 7018 at the 120. And because this has no differing settings available for it, we're just going to run it the way it is and not make any changes. All right, let's get into it. I'm going to start by running a 1/8 inch 6010 at 90 amps. A lot easier starting on 240 volts, and I've noticed that in the past, but you can see didn't have any issue with the start on that. All right, so before we get into the actual test results and talk about efficiencies, and there's some eye-opening differences there, but I want to talk about the accessories that it comes with. And this goes with the Rogue 200 and the 180. So keep in mind the 200 that I have comes with a TIG torch. We're not going to talk about that. We're just talking about what's used for stick. So the first thing where the rubber meets the road, the stinger. This, which is KV200, it's the cheapest stinger known to man, and I don't like it. So I hate to trash on something, but let's be honest, guys, this thing sucks. And about the only redeeming thing is that I can fit my big old paw in there underneath this. Now, I don't normally hold a stinger this high, but maybe occasionally I will. I generally grab down here. So this is more comfortable for me in my big hand versus even the Tweeko. When I grab that, I can't fit my knuckle under there, okay? So that's one redeeming thing about this guy, but that's about it, to be honest with you. So the good news is you can upgrade this directly from Harbor Freight right in the store when you buy this, and 100% you should. Because you'll never, if you grow accustomed to using this, and don't get me wrong, there are certain benefits to this because it's small. When you use any kind of other stick welder out there, they all use bigger styles like this. Get used to the bigger one than this, honestly, so upgrade this. Now, the Esab one, super heavy duty jaws, super strong spring. I mean, this actually does have a decent spring, but the jaws on this, so much more metal in there, so very, very much stronger. This needs no upgrade. It's not my personal favorite stinger, but you don't need to swap this out. This 100% will do anything you want to. Let's talk about the ground clamps now. So, standard cheap sheet metal. The spring pressure on this, honestly, is pretty light. I mean, I got good grip strength, but this is pretty light. Has just stamped zinc-coated jaws, very small strap, grounding strap to the other side. Cable-wise, they claim this is 6-gauge cable. I would tend to agree with them. It does appear to be 6-gauge. And looking through the inside, it appears to be solid copper wire, so that's a plus. A lot of times with cheaper power cable, you get what's known as copper-clad aluminum, CCA wire. That can't handle as much amperage as this. At least at face value, it appears to be pure copper, or solid, stranded copper. I mean, not solid copper, you get the idea. Not really that heavy duty, but it will work. If you're gonna plan on welding above 170-80 amps with this machine, honestly, you would probably wanna upgrade the power cables on this. Now, keep in mind, you're using DINS 25 connectors, and we'll talk about those in a second here. So how much of an upgrade are you getting going to bigger wire? Well, a little bit, but the connectors will also hold you back. Now, Esab includes also a stamped sheet metal ground clamp. It's better in quality, I would say, than this. It's a little bit thicker, and I'll tell you what, the spring clamp in here, much stronger, much bigger ground strap. I don't know if you can see that, but much bigger ground strap. The bolt on top and the eyelet are bigger on this, which that's a good thing. Now, this cable is not American wire gauge on this Rogue. It's actually metric. And the reason I say it's metric is because, well, it tells you right on the cable, but when I measured it, this doesn't really follow a American wire gauge. I would say it's maybe slightly bigger than 6-gauge, so like 5.5 gauge or something. It's not 4 gauge, and it's not 6, so that's what we'll call it. Again, seems to be solid copper, does not appear to be copper-clad aluminum. This is adequate for the intended use of this machine, being 170-80 amp stick, 200 or so TIG, so I wouldn't worry too much about this for amperage capacity. Now let's talk about the connectors. So both of these use DINS. This is DINS 25. It's roughly a 1/4 inch solid terminal. The Esab uses, and I don't quite understand the difference, sometimes it's called DINS 50. This is labeled actually DINS 3570, but you can see how much of a difference there is between the conductors. So which one will handle more power? This guy. Which one will attach more strongly to the case or to the welder? This. Is it necessary? Well, surprisingly enough, even Miller on a lot of their stick welders, the smaller portable units, they use this style too. So is it really adequate for the needs of this machine? Well, if you look here, it says 200 amp rating, 25 to 200 amp, or actually that's a part number 25, but 200 amp rating. This is capable of 225. Realistically, I feel this connector's a little undersized. I wish they would have went with this size, but most of the people that are going to be welding with this will be nowhere near the 225 amp output. So that's really kind of a moot point, and I don't really see that as a problem because, again, I'm honestly happy that Harbor Freight came out with this unit and made it available, because for the price, you really can't beat it because it welds really good. Speaking of welding, let's compare the actual welds from both machines. So here are the welds that I did with the Esab. We'll start out with that first. So this is 6011 that I did at 60 amps on 120 volts, 6010 at 90 amps, 7018 332 at 90 amps, 7018 1/8 inch at 120, or well, 110 amps. These are all on 120 volt. Then I switched over to 240 volt, ran 1/8 inch 6010 at 90 and 1/8 inch 7018 at 90. So quite a gamut of welds here. My thoughts on this, there is a significant change when you run the Esab Rogue on 120 volt when it comes to starting rods. So this 6010 at 90 amps was kind of a bear to start. It wasn't impossible, but it definitely took a lot more work, and that's something I've noticed with most stick welders that do dual voltage, is that when you run them on 120, the starts just aren't as good. And part of that is that I believe, if I recall, there's a reduction in output voltage open circuit when you drop the voltage with the Esab machine. So basically it's not outputting the same open circuit voltage, and that's probably why. But I tried, in the past I've noticed that with the welder, and I've ran hot start, higher, all sorts of things. It just is more difficult to start on 120, just is what it is. But all of these beads, I would say very acceptable. Again, won't win any beauty pageants, but I was just more or less trying to get some metal down consistent to get some data. So overall, it welded pretty good. It tended to weld on the hot side, and when we look at the actual results from the testing, you'll see that the Esab machine did tend to favor 7 to 10 amps over set point, and that's likely why they were a little bit hotter. So now let's look at the titanium 225. So this is a Harbor Freight side. I ran things in a little bit different of an order just because of, well, I was limited to only being able to run 6011 rods, unfortunately, that I had for 60 amps on 120. So both of these, it's just 2 passes of 6011. I did 2 because, of course, I forgot to hit record on the first one. But it runs 60 amps, no problem on 120. And it'll run 6011 332 all day, no issues there, ran really good. So these are the only 120. Now on 240 volts, I ran this guy, which is 6010. This machine does not have anywhere near the hot start, and it is a little bit harder to strike an arc with the titanium than the Esab Rogue, especially with 6010. Once I got it started and settled down, it welded fine, but the rough start, partially because I'm not used to how it starts and partially because of the lack of hot start. But once you get into the meat of it, it welds fine with 6010, no issue there. This guy right here is a 332 7018 at around 90 amps, ran exactly like I would expect. The hot start issue, maybe I just got it solved a little bit better for this, you know, realized what it was doing, but, you know, it worked. This guy right here is a 332/6011, so I ran that on 120 or on 240 volts as well, just to see how it would run, and it ran okay as well. No real issues there. And then here is a 1/8 inch 7018, and I ran that at 120. Again, no real issues. The welder welds very good from what I've seen. I wish it had a little bit hotter of a hot start. It seems to be like a couple amps and that's it. So that, and of course it's not adjustable, but again, very acceptable for just a couple beads on plate. Just looking at them, I would say that there's no question that the Esab runs hotter, and the data will support that. So let's look at the data. All right, guys, I got a metric shit ton of data from all of the testing I did, and don't worry, I got a little bit better, more organized page than this, but this is the raw data, or at least most of it. Let's start out with this, which is a little bit simplified. So the data that I collected, I came up with efficiencies in how much power they drew. Now the Harbor Freight, this is 120 volts. Harbor Freight running 6011 332 with a set point of 60 amps actually outputted 66 amps, which is very close or close to the set point. And remember, it's not a digital display, a little bit harder. So it ran at 26 volts, which is in line with what 6011 runs at, for a total of 1,716 watts of output power. The machine drew 25 amps off my generator at 120 volts. Keep in mind my generator is pure sine wave output, so these numbers will be accurate to what you would pull out of a wall. So 25 amp draw, 3,000 watts is what 120 times 25. You divide the output wattage by the input wattage, and we get a 57% efficiency. So I figured somewhere between 50 and 60, I am in the ballpark of accurate. Now, in contrast to that, the Rogue, same rod, same amperage set point, it outputted the same amperage, so 66 amps, 26 volts, which the voltage is the same because I ran the same arc gap, and the wattage on output is the same in this case. Now, the Rogue drew 17 amps at the 120 for a total of 2,040 watts, which again, output wattage divided by input gives us a 84% efficiency on 120 volt. So massively more efficient. So the Harbor Freight unit is going to take 3,000 watts just to run that rod. This is going to take 2,040. In theory, and this is a big theory, if you had a 2,500 running watt generator with the Esab Rogue, you could realistically run a 332/6011 on it at 60 amps, and it would not kick out the breaker, and the generator would handle it. In the case of the Harbor Freight, you'd need somewhere around a 3,500 watt generator with over 20 amp breaker on it, which that's going to be a bigger issue, because if you look here, this drew over a 20 amp outlet or a 20 amp breaker. Now in a household, a 20 amp breaker will allow 25 amps through. On a generator, the breakers typically trip exactly at their rating. So this will not trip a 20 amp circuit on a generator, a 20 amp breaker. This possibly will. So that's something to consider. Now, I was not able to test these rods on 120 volt, but I'll give you the brief overview. 6010 on the Esab 1/8 inch rod did run. It drew 29 amps in order to run it. And I had said earlier in the video is that household breakers allow more amperage through than the rating, and that's because they trip on a thermal trip. So this unit probably would run 1/8 inch rods on a 120 volt circuit in your house for intermittent use and not get a breaker trip, even though yes, 100% it is drawing 29 amps. Now on my generator, I had it hooked to a 30 amp outlet. If you do not have a 30 amp outlet on 120 for your generator, you will not be able to run this on your generator. It will likely pretty quickly trip a generator's 20 amp, but in a household, you'll probably be all right. So anyways, here's the output wattage and input wattage, 83% efficient. And we'll just go fairly quickly here. You can pause it if you want to read the details, but it will run a 332 7018 at 90 amps, 80% efficient. It will also run 1/8 inch 7018, 81% efficient. One thing I thought was interesting, as the amperage went up, its set points were off by more. So the machine claims to max out at 110 amps on 120 volts, but it actually output 123 amps at 110 setting. But again, efficiencies somewhere between 80 and 85% efficient, so highly, highly efficient on 120 volts, and this not so much. Now, as to a possible reason for that, one, probably a more efficient inverter setup in the machine, and two, I know it has power input, power factor correction capacitors and circuitry, which will help it maintain efficiency at lower voltage, and it will also help to a certain extent at higher voltage as well, to 240 volt. So I think you gather this. The Esab is much more efficient. Let's look at 240 volts. So 240 volts, much the same for both machines as previous. So long story short, again, you can pause this if you want to read the actual data. I'll skim over it a little quick. To run 6010 1/8 inch rods, this needs 4,800 watts and 56% efficient. So it is wasting 44% of the input 4,800 watts to run that rod. The Esab Rogue, again, 90 amp 6010, is only drawing 13 amps, not 20, and is 89.7% efficient. So basically massive efficiency difference. So you could run on a 3,500 watt 240 volt generator, you could run 1/8 inch 6010 with the Esab. You would need at least probably a 5,500 watt generator to run the Harbor Freight to get the same output with the same rod. Go down to 1/8 inch 7018, long story short, 51% efficient, a little bit less, and versus the Esab 89% efficient. Now, if there's any takeaway so far, two things. One, the Esab's efficiency is actually higher on 240 volts versus 120, not by much, but it is. And the Harbor Freight is actually closer to the set point than the Esab, which I kind of didn't expect that, but props to Harbor Freight on that one. Now the 332 7018, 90 amps, efficiency 48%. So it took 4,320 watts to run that 332 rod, 18 amps. The 7018 on the Esab, it only drew 10 amps, so significantly less, 2,400 watts, 90% efficient. So double the efficiency. So basically, you could get by with like a 26 to 2,800 running watt 240 generator and run a 332 7018. This guy, you're going to need probably 47, 4,800 to be safe. So quite a huge, staggering difference in efficiency, but I expected that going into this, and that's what we saw. So let's go and talk about what this really means. I know that was a lot of data to throw at you guys, and I don't mean to make it more complex than it needs to be, which is why I'm just going to do a brief recap and then we'll go to conclusion. What the data to me really suggests is that the simple fact is the Esab is staggeringly efficient. It's actually the highest efficiency I've ever tested on 120 and 240 for turning input wattage into output wattage. So that's amazing, and that's amazing in the sense that you can use a far smaller generator to run this, It will run better on a generator because it has power factor correction. So poor quality generator power will likely not affect this as much, which is good. And you can get by with just flat out smaller circuits. On an average 120 volt 20 amp circuit in your house, in your garage, you'll actually be able to do some decent welding on this 332 for sure without tripping a breaker. Versus the titanium 225, on 120 volt, you're going to be rather limited. And realistically, if you tried to go over 60 amps, which it does go to 70, at 70 amps, you're probably going to have nuisance breaker trips or be right at the cusp of that. And that is why this machine only goes to 70 amps and not higher, versus this goes to 110 for a set point. And that's because its efficiency is low enough that it's already pulling essentially over the breaker's rating at 60 amps. Now, realistically, this is clearly designed to be code compliant, because if you go on Amazon and buy a cheap stick welder, which I even have one of those, and honestly, just buy this thing over a cheaper stick welder, but whatever. You buy one of them cheap $100 specials, they don't give a two rat's ass about how much power they pull from a wall, and they'll pull 40, 50 amps on a 120 and trip your breaker. You know, this thing was designed and engineered to get to the limit of what would be acceptable and not get too many nuisance breaker trips. So this was engineered with some kind of electrical code compliance with it, which is a good sign, and it's going to be far more useful from that standpoint than the Amazon specials that are just going to trip your breaker. Now, it's still, 100% due to the lack of efficiency on the inverter design, the lack of power factor correction on this unit, it's going to eat a lot more power. The question is, does that matter? Well, for you, if you're running on household power and you have 240 volts, absolutely not. The fact that this is more efficient, so what? It's going to use a few pennies in a day less electricity on that guy versus this, but other than that, the efficiency doesn't matter. But for you guys that run on a generator like I do, or you want to go mobile and do mobile welding, you're basically getting 40% more output on this over this at the same voltage. And that allows you to do two things. One, probably run a smaller generator, which a smaller generator is cheaper. And two, if you have a bigger generator, you can get more output and be welding a lot thicker plate with that than this guy. Now, I didn't test this at 150 amps, but based on the trends I'm seeing, it's going to be 50% efficient at best. This guy's probably still going to be above 80%. So flat out, you're going to need a lot bigger generator with this than that guy. So it gives you more options to buy this, because the money you would save in buying a bigger generator, you can spend on the machine rather than the generator, I guess would be one way to look at it. And again, these numbers are based on my testing in a small sample size, but realistically, they're going to hold up across the board, I think. And it really goes to show that there's far more at play than just spending $500, $600, $700 more for nothing. And that's what you're going to find. It's not just these welders. Generally speaking, you're going to find cheaper welders are just not efficient. More expensive ones generally are. And keep in mind, both of these are inverters, and they have massively different efficiencies. If you're trying to weld with an older transformer, non-inverter stick welder, those are like 30 to 40% efficient. So you could probably get over double the output on the same amperage input with this over one of those. So all things to think of. Let's go to conclusion. So I know that this was a long video. I hope that you guys learned something about this and you realize that when it comes to welders, you do get typically more for your money. And so much of that is often things that you don't see, or you don't see on spec sheets, or you don't have a feel for until you actually use them. And I can tell you, after welding with both of these today and just fooling around with them, There's a lot of things that I like about both of them, and I'm not making this video to crap on this guy because I knew that the efficiency wasn't going to be there. I mean, how could you get high level of efficiency for sub $300? Let's face it, that comes with money. But what I want you to take away is that if you're not running on a generator and you're just going to set up in your little home shop, your garage, and you got 240 volts, this guy is going to do a lot of what you would need to do. No, it doesn't have all the adjustments that you might want like this guy does, or the 180 version, but it's a very serviceable welder. Its stick welds awesome. Now, if you're limited to 120 volts or on a generator, you're going to want to seriously look at spending the money for the Rogue 180 or the 200. They're just far more efficient. And there are a lot of other small form factor welders like this that are also highly efficient, like the Miller 161S, which is a stick welder, the Fronius Trans Pocket, I think it's called, 180, also likely in the 80 to 90% efficiency range, which it just buys you so much more output and no nuisance breaker trips, and you can get a smaller generator as well. Now, beyond that, the quality of what you get for components are going to be better with the more expensive welder, but let's face it, we knew that. The stinger is better on here. The cables are more flexible. The plug ends are a little bit better built. The input-output terminals are beefier on the Esab. The buttons here, well, granted, this doesn't really have buttons, but everything about this is built really well, as are most professional level compact welders. This guy, very simplistic, but the awesome thing about it is, and I kind of sit here laughing about it, this was more accurate to the set point. If you put it at 120, it was only a couple amps above it. This guy was 11 to 12 amps above the set point depending. So I find that kind of humorous because clearly LCD display isn't really the end-all be-all. I mean, when it comes down to it, if you want 120 amps, what does it matter that you have an LCD versus this? I mean, it works just fine. Now, from my take, is it easier to weld with the Esab? Yes. Both of them don't really start the arc that well on 120 volts, I'll be honest. But on 240, it is actually easier to start an arc with 6010 with this, 7018, they're both about the same. But the fact that you can have set points for arc force as well as hot start will just help you dial in a stick weld better. But if you're a beginner or just learning, that isn't a huge difference. And that's why I really preach about this machine here at $300, well, sub $300, and versus, you know, $800, $850 for the 180 version. Which is going to make you a better welder if you're learning? The answer is the one that you can afford to buy and buy steel and rods. Buying this sucker and spending the difference in price between the two of them on steel and rods would make you a far better welder than buying this and running 10 rods in the whole time you owned it. So that's something to think about. You know, I used to be a pistol instructor for teaching people how to shoot accurately and stuff, CCW and that, okay? When I taught those classes, it was very common to have some guy or girl show up with like a $2,000 like super accurate pistol, and they couldn't shoot it very well. And I kind of always laughed about that, and I can relate it to this, is that a particular tool doesn't make someone better, especially if you're at a novice level. It might a little bit, but what matters is practice and time using it. And that is the best, you know, analogy of what's going on here. If someone had bought a $500 pistol and $1,500 of ammo in practice, it would probably be a far better, and training, a far better, you know, marksman than someone who just spent a bunch of money on the tools. So something to think about. But with that said, if you got any comments, questions, thoughts on this, feel free to leave them. And as always, thank you guys for sticking around. Until next time.